Hello. Welcome to week something of RIT Sec. This is the Red Team Talk. Um, I decided, just so it's no, I decided to dress as my favorite sweater, which is fluffy because of that. But let's start. What is Red Team? Well, Red Team can have different definitions depending on who you talk to. Red Team outside of this club room is considered pen testing. Uh, If you guys go to Harvard, you would know what pen testing is. Essentially, you're just testing the system for a bunch of vulnerabilities, and at the end, you write a report, pretty much school, outside of school. But the cool part, red teaming, or also called adversary simulation, is where you do, or where you try to act like a threat actor. So you try your best to be under detection. You try to write some really sneaky tools and try to test. The goal for that is to test the blue teamers, so like the incident response folks, just to see how they can respond in a really tough situation. And there is vulnerability assessment or compliance. This is not similar to pen testing, but you can think of it like that, except you just have a list of compliance and see if their system follows all of that. Like I said, pen testing is trying to find a lot of vulnerabilities, hone as many systems in that testing environment or client, and you try to show why that vulnerability is important to fix. Because you can have like 20 vulnerabilities, and they might decide to just fix one. So you have to really prove to your client that you have really, that the vulnerabilities you find are really dangerous and they should be fixed ASAP. And for pen testing, what you really sell is your report, not your findings. So you kind of have to be good at rewriting and describing high level, like really technical stuff in a high level manner. So red team. Well, it's a lot. It's pretty cool. It requires you to be more knowledgeable in whatever operating system you are targeting. I know a lot of people would do Windows. So for Windows, you would need to know like how the internal works, how everything is supposed to work as normal, and how you can take that to your advantage. I think we have a bunch of tools that kind of exploits the way Windows work. And when you're in there, you try your best not to get locked out or to lose access to the machine. So you have a lot to think about. Rather than just writing your fancy tool, you need to find a way to really go around the system and grab some information and just be as quiet as possible. Because again, you're trying to be a threat actor. So think like one, be one. No, don't be one, but you get the point. Depending on the client, sometimes you do need to write reports, but again, that's not the main focus. It's just more of testing the blue teamers and how they respond to the type of attack you do. So, yep. So for this red team, there's a few things. Persistence is the big part. You always need a way to go back in because, again, someone is going to find you and they're going to kick you out, and you always need to find a way to get back in. There are multiple ways you can get in. So still kind of like in that pen testing kind of mindset, you would need to find like misconfigured services or vulnerabilities to get in the system first. For example, if a web server, for some instance, is running your arguments when you type in your name, you can use that to your advantage by passing it like a system command, all that fun stuff. And in our competition, it's more fun because halfway through the competitions, we just like meme on you. So instead of doing something malicious, we just put like not Flappy Birds, but like a dancing character on your screen just dancing around, or we can just rotate your screen. That's what we do as a red team at RIT, but outside of that, it's different. I don't think anyone knows because we don't work there, but it's slightly different. So just some keywords. Vulnerability, if you've taken CSEC 101 or CSEC 140, you would know this by now. It is just a flaw in a system code that you try to use to your advantage. It's mainly like there's a few things. Coding errors, mostly coding errors. Like example, buffer overflows is just how you parse a user input. So that's at least an example of buffer overflow. There's also system misconfiguration. So if you, for some reason, say every user can run sudo on a specific binary, they can use that to become root. Also, if you just have weak passwords, never changing your passwords, that's considered a vulnerability. Yep. Exploits. Exploit is taking the vulnerability to a next level. So you found the stuff, and now you need it to work for you. So you write some kind of proof of concept, or POC, or tool to take advantage of that. An example that recently happened is the log4j. Yes. There's a vulnerability in the login packets, and people wrote a bunch of POCs to get code execution. That's an example of exploit and exploits working together. And there are modules. Metasploit is a big a framework that really helps with exploiting some stuff. They already have like predetermined exploits. I think one of the common one is the MSF 140, I think. It's an exploit in Windows XP. So they have a lot of modules. You can always just take a look and play with it. So threat. This is someone or something that wants to cause or like make you suffer, and they have a goal in mind. Really depends on the actors. Obviously, if they're state actors, they do not necessarily care about money. It's more about intelligence. If it's some kid, I don't know, I forgot the word. If it's one of the new hackers, obviously they just want to either get money or try to be the best in their little group. For here, we are none of that. We just want you to learn. We're not a threat. We are your friend. Yeah. But as a red teamer, there are a few life cycles. This is what we follow. Pretty straightforward. It's first you get the initial access, or you do initial recon, so try to get as much information from your target. Then you get find a way to get onto that system, into your target network. Then you try to establish like a foothold, something that can give you like some kind of command execution or something. Then from there, you try to be the highest user as you can be. So from like user Jake to user root. And from there, you do more reconnaissance, just see what else you can find. You try to move around into as many systems as you can. And again, you just try to try to hide in the system as long as possible. And at the end, you can try to gather some like data, like information. So depending on what your motives are, you might try to get some really like documents or money and all that stuff. All depends on you. But after all of that, then you're done with your attack. A good outline that we use and people outside use is the MITRE ATT&CK framework. This is pretty much where we get like most of our tool ideas. Not mostly. That's where we get all of our tool ideas, because they're pretty cool. So if you really want to like start red teaming and just understanding how a red teamer would think, this is a good place to start. That's always my go-to. And like I said, this is the kind of the list. I guess the one I never mentioned is the command and control. This will be used during your persistent stage. So you get persistent, and you also need a way to constantly like see if your target is alive, and if you can like run commands at a specific time, or just having control, because you might also want to use a bunch of targets to do a DDoS attack, like they did to RIT a few days ago. So if you want to do that, you would need a command and control center to kind of create that attack. So now we move into red teaming, again, back to RIT. So a lot of steps are kind of skipped because we don't need them. For example, the the first step is not initial access, it was the recon. In our case, we don't have to do that because we work directly with the gray team and we don't need to try to find out what machines you guys have and all of that fancy stuff. We just have it. The initial access though is the deployment. So when we're allowed to put our tools in there, we need to deploy all of that massive 29 plus tools on high school in one night. So after that, we go into the persistence. The tools we create does have some of these techniques all together. There are some that can evade defender using some really interesting methods. But most of our persistence in this list is the command and control. This is just so we can change break your services, patrolling you guys and all that stuff. So we do a lot of that. And sometimes we do a little bit of data collection, like a password. That's it. We like passwords. But like I said, some of the things we kind of don't do is the privilege escalation, lateral movement, and the grabbing of data. We are trying to look into those three and see what we can do. I think we have something in the works, but as for right now, we don't have something we can talk about. So, for red teamer, what do you need to? How do you get started? So if you're on the team, there's a lot. First, you have to again work with the gray team and get the topology and the packets and just know what you can do and what you cannot do. For instance, you cannot run Flappy Birds on the first minute, because at that point, no one can use the computer and it's just useless. So stuff like that, you kind of need to have a good communication with you and the red teamers, and the gray teamers, and also with the people on your team, so that everyone knows what's going on. You need a plan and a software to throughout the whole competition, you need to know what to do at a specific time, because you don't want to do all of your attacks in the first 5 minutes. It gets really boring pretty quickly. So have a plan. We call it the break schedule. Just what you do at a specific time. Nothing too useful to most blue teamers here, but that's something we do. And also when you're unclear on what's allowed and what's not, always talk to your gray team or white team, mostly the gray team, because they are the one developing the system. So, yeah. And this part, the organize your team, this is mainly on the red team itself, so you need a red team chief or leader. In this case, it's me. And from there, you can assign smaller roles. For instance, we have the Windows lead and the Linux lead, because I could, in theory, do all of it, but that's a lot of work for one person. So it's better to divide the work. And Enzo over there is denying his role as a Windows lead, but he is. So if you have any Windows questions, Enzo. But apart from having roles and all that stuff, the key part is just communication with each other. There are going to be some conflicts in what's going on, are we supposed to deploy this? Has this been deployed? What's the password? All of that stuff. You need a chat. You guys have the red team recruiting. You guys will go in there and just make sure everything is okay. Just hopefully people reply. They don't, but try. And you also want to know what operating system you are good at or you want to focus on. So mostly we have the Windows, Linux, and router. So we have folks for Windows, folks for Linux, and folks for routers. It is okay to want to do all of it. The reason why we say have a main one is because we don't want to have 10 people on Linux and 1 person on Windows. It becomes really unbalanced. And in this case, we need more router people. At this point, it's me and just Jason and a few others. Not a lot. So we would love a lot of people on the router side of things. Deployment. Whew. There's a lot of debates about this one for some reason. Before we get there, what you need to know is the IPs, so like know what the target IPs are, the default passwords, and what OSs are there. Pretty much all of this will be provided in the packets. And the part that says all about speed is just like what deployment tools you use, which we'll talk in the next slide, I think. But I don't think in a competition like this, like in a school environment, I don't think speed is that much of an issue, because usually you would have, like, as a red team, like a week or so before the competition, so you have a good amount of time to deploy your stuff. But there are cases where everything just breaks and you have to deploy minute zero. But if you properly plan your deployment, you can also deploy on minute zero and have access to the machine at the same time as blue teamers and still have access to all of it. It is possible. But as you go on, we do have like a list of things we already have, tools that are already stable. So rather than writing like the same script over and over for different competitions, you can have a predetermined script that just does the same thing. Like you can just run one script and it does all of it. So what do we use? This was taken from the last time this talk was given. At that time, no one loved Ansible. They claimed it was bad, it was slow, it doesn't work for Windows, blah, blah, blah. I was like, okay, suck it. But now this is 2022, and we have Ansible, a centralized one, which means you don't even have to do a lot. You just have to run Ansible playbook, some arguments, and that's it. I'm going to show a demo for this. A demo that I'm going to deploy on an actual team that we have a competition for tomorrow, and you guys will see how it goes. So we use Ansible. I made it kind of standardized. So it's, if you want your tool to be deployed, you have to push to the repo where you do that. You can use Metasploit. I don't know why, but you can. You can use Deadcord, which was a replacement for Ansible. It's claimed to be faster, but it doesn't work for Windows half of the time. So take it as you will. But it was created by one of our red teamers. It is pretty good. So if you want to be more of a tool developer and fix stuff, Deco would be, I think, would be a good place to start if you're really interested in the way deployment works. Again, I think it only works for Linux. There might be some bugs with Windows, and you can decide to fix it. But if you don't have all of those fancy tools and you want to go the old route, which means just using SSH, bash, and all of that stuff, you have that, but it makes it a little harder because, I mean, you can write a bash script that can SSH into multiple boxes, which is what Deadcord does. You can do one by one, like deploying to 60 teams, like Michael over there. It's possible if you want to, but it's not recommended. It gets really annoying, and it's not the technique is not usable over a longer period of time. So I would like to show this demo-ish. So this is something you don't even care about this part because it's useless, but this is Ansible, a quick view. We have this that just says, oh, I want you to deploy Discord Go. It's public, you guys know where it is. There's no need to hide it. But we are deploying Discord Go to a bunch of teams. IP address we'll show later. And yep. And this is just a service file. I don't think that's really useful, but the goal of this is just this. We want to deploy Discord Go to a bunch of hosts. And if I run this, if I can zoom in first. Is that okay? Can you guys see that? Yeah. Okay. So I'm going to deploy Discord Go on a bunch of test teams. We're just going to see if this works. See, it connected to the 4 teams, copied the Discord Go, and it's running Discord Go. Simple. Look at that. And we don't have to change this a lot. All we have to do is probably just change the IP addresses, and that's it. And now we can do this at minute 0 if something happened and we have to deploy the same time as blue teamers start, we can just run this at the same time and we should be fine. Just to show you, those are the machines over there. You guys know how it looks anyways. There's no need to hide this. Right there, boom, Discord magic. Ha. Just a shameless plug for me. But that's it. So persistence. There are multiple ways to do this. I think I just showed one right here. We use different methods. Most people use the service file. It's just a service that runs in the background. Depending on how you set this up, it can do really cool stuff. But as Daryl will say, 1 is none and 2 is 1. I think that's Daryl. Essentially, have as many persistence methods as you have. If you have one, that's good. But if you lose it, then you lose everything. So it's always good to have multiple ways, and even during competition, just keep adding more. If you think you're going to lose it, just keep adding more ways to do so. There are some ways. The common or the easy one you can think of is reverse shell, or people call bind shell, depending on where you think about it. Like it says right there, think of SSH without a password. So you just connect to that port, and it just gives you a shell. An example is you can have nc-lp444-e bin bash. This is saying I want this machine to listen on port 444, and when someone connects, I want you to execute the bin bash. And when you do nc, the target IP 444, it's going to give you a bash shell. Simple. Pretty easy to do. Again, we do a lot of service stuff. We backdoor different services. So we have Nginx, Apache, GitLab, Mail, and other stuff. This is just some example. We have the Edgeshot, which is the Nginx backdoor, and we have the Vishnu, which is sort of a reverse shell, but hidden. I gave a talk about it, so if you want to look at that. But another one, reverse shell. There are multiple ways. Again, you can write yours, or you can use some of the public ones that are stable. Empire, I think, is dead. It's not being maintained, but you can still use it. Metasploit, obviously everyone uses that a lot. It's pretty fun, easy to use. Merlin, Poppy, and there's a lot. Pretty cool stuff. So from a red team point of view, we have our own. Okay. Oh, shit, that was loud. I just hold it like this now. So we have our own version of the topology because we have a lot of tools, and it's easy to get overwhelmed with those tools. So we have multiple C2s, and a way to make this cleaner is by having a team server. And you can think of it as a C2 for C2s. So instead of people trying to go to your own C2 and using it, it can be difficult to use. So we would have like a team server. In this case, it's called Hivemind. It's public. Still when it works, but it's there. So essentially, all our C2s would talk to the team server, and from team server, it talks to the target. And this way is just a way for multiple people to kind of see what's going on. Like it can be used to see like what command was ran at this specific time, and also like what access do we have from what C2. Pretty cool stuff. When you come to red team recruiting, we talk more about this. So how do you do that communications? Well, multiple ways. Simple way is just using sockets. If you, again, red team recruiting, you're currently creating a C2, and that's that. You just send your traffic via HTTP. You can do different protocols. You can use HTTP, pretty cool, but not encrypted. You can do DNS, pretty sneaky, pretty cool. You can do HTTPS and ICMP. There's multiple ways. You can also encrypt your commands like base64, XOR. encrypt/encode your commands. You can do that. And you can be creative, like piggyback off another tool. Again, Discord Go. Today I was showed another one using Skype, so that's another way to do so. So you just got to be creative sometime. So persistence. Again, there are multiple ways. These are some of the ones we use: cron job, task scheduler, bash RC services, startup commands, registers, and again, you can be really, really creative by using like things like hotkeys, kernel stuff. You just have to be really creative. There's multiple ways for persistence. Some of the things we do, or some of the common ones, are web shells, SSH misconfiguration files. Sometimes, by default, the root is not allowed to log in, but you can just turn it on. That's a misconfiguration, because now you can just log in with root user. And if you don't have the password, there's SSH keys. Most people forget that is there, so always look at your SSH folder. For Windows, you can do RDP, which allows PS exec. That's all I got to say for that. I don't know that. PAN backdoor, you guys, some people should know this. There's a lot of PAN backdoors out there. You can look it up on GitHub, and there's like different methods. And sometimes we go really, really easy and just create users, like quant1. Like, that's not a user, it's just there. And if you look at the sudoers file, it has root privileges to do anything. So always look at like specific files that gives permissions. For Linux, etc shadower, sudoer, I can read. For example, this command says any user that's right here can run any commands as root with no password, as any user with no password. So this is a misconfiguration that we use. For Windows, you can add a user to the admin group. Like, again, if you see if you see Quantum, I'm not going to say that, into the admin group, it's like, and the thing is, in your red team packets or in your blue team packet, it tells you the legitimate users. So it's really easy for you to know what's a legitimate user and what's not. So easy way to solve all this problem. Again, these are just some easy stuff, general misconfigurations. So for data collection, which we don't do a lot, but like when we do, the key part we do is look for firewalls, keyloggers meaning your passwords, and sometimes we find some good stuff like your firewall script or some kind of tool to fight red team. So we can even use that to our advantage. Rather than deleting that file, we can just edit it to do whatever we need to. So we pay attention. So when we get access, we just don't sit there and just wait for you to do something. We also go in there and see what you're doing. So we are watching you, pretty much. Yeah. Some Linux stuff. Persistent in Windows. Linux is, again, cron job, system services, misconfiguring services, and backdoor services. Let's see, is there anything here? Cron job, really easy to find. You can tell it to execute specific commands, scripts at a specific time. So if I wanted to run a script every 1 minute, I can just do *******, and the path to the script or your command. It's really easy to find because you can just do cron job -e, and it shows, well, cron job -l, and shows you all the cron jobs that is for that user. And if you want to delete it, just do cron tab -r and the username. There are different levels you have for users, and there's a system-wide, so you want to check both of them. Services, again, just like I showed you before, it's pretty easy to write, at least for Linux and not BSD. The fun thing about this is they run in the background. So if they crash, it doesn't necessarily tell you. You just kind of need to know or constantly check that. But again, it's pretty cool because you can have it execute your malicious code or malicious stuff as a service and running in the background. But also, you can, if someone did stop it, or if the service for some reason breaks, you can make the service restart if it ever stops. So that's a cool feature about the services stuff. Again, misconfigurations, depending on how we do this, it can be hard. Permit login, really easy. You always want to set that to no password. You don't want the root user to log in. And you can also like do specific users. Like if you just want your user to log in, you can say only my user. We can configure PAM to allow any passwords. Yep. And this is some random trick that John Bauer uses. I didn't put this, so if I get flamed for this, it's John Bauer's. The input RC is where your kind of configures your input stuff. You can remap keys. Yes. A cool one is the prompt underscore command. Every time you run enter, whatever you put there is going to be executed. So in this case, you press enter, you just delete your firewalls all the time. And if your machine is like something you can have direct console and has sound, we can say that every time you click on something, you can play an annoying beep every time. So fun stuff. And the funny stuff, or the cool one, is the kernel panic. Like, and so it's writing right now. Yes, just echo one into those files, and your computer goes crazy. I don't know why, because this is not my trick, but cool stuff. Okay, I am Windows. I don't know this one. Metasploit. People use Metasploit for Windows, apparently. It's really used. You can use it to set up a listener, exploit a vulnerability. I think at one point we used it to exploit, what was that exploit, the big one? Zero logon. During a competition. It was like after the competition was created, after the vulnerability was released, and it was like, oh, why not just use zero logon? And it did work, but I think it broke some stuff, but it worked. So fun stuff. Yep. That's all I got to say for that. And there's just a bunch of modules. There's no need to go into them. Oh, wait, actually. The top one, the Mimikatz, that's a pretty good one, at least using pen testing and just in general. It's like a memory kind of stuff. It kind of grabs your credential from memory, right? Yeah, pretty interesting method. You would think this is some vulnerability in Windows, but no, that's just the way it works. So it's like taking how it's supposed to work and just using to your advantage. So Red Team, again, needs a little bit of like in-depth knowledge of whatever operating system you're playing with. Yep. No. Persistent on Windows. I guess there's multiple ways. I'm just gonna, first one I know of is the scheduled task. Think of it as cron job in Linux. Pretty cool. That's how you delete it. Yeah. More Windows stuff. SMB. Yes, I don't know Windows, as you can tell. I'll give to the Red Team lead, the Windows lead, to do so.
I hate Windows. Thank you. And this is the last Windows thing I'll ever do, I swear. Okay, so SMB is a protocol. It's usually used for file shares on Windows, but usually we can use it to our advantage. So often it's a really outdated and insecure protocol. And often the biggest thing with it is you can write to, if you have write access to an SMB share, you can write to it. So say you have the ability to execute a command, you can write your output to the SMB share and then take your output from there. And that's how some common tools like this work. Like PSExec is the biggest, it's the most popular like Windows remote code execution tool. Basically what PSExec does is remotely through commands, you don't have to be on the system or anything, you run this thing and it'll install a service on the other person's machine. And then it interacts with that service to execute commands. And you're running as NT-auth system, so you're the highest levels of privileges when you're running that. The problem is it's super loud, it creates a bunch of logs. You can clearly see PSExec service in your services if someone's using it. You'll know what IPs it's coming from if you check your event log, and stuff like that. So moving on, net use. So what I was saying earlier about the SMB shares, if you have write access to an SMB share, there's a lot you can do with that. So just watch out for poorly permissioned, misconfigurations in your SMB share. And there's some extra ones too. SMB exec is built into this thing called Impacket, which is basically a bunch of Python tools that can interact with Windows and do these PS exec, SMB exec, anything with SMB really. It creates a service, but it does it in a more stealthy way. I don't remember exactly how it does it, but yeah, that's SMB exec. The registry, okay. This is huge. So by default, when you install Windows, and this was Windows 10, there were more than 3 million registry keys installed. And that's before you start installing software and doing all that stuff. So this is where everything is kept. All settings are just kept in this giant database. So some of these specific registry keys are specific to what Windows uses. So the one right here that's most popular for red teaming is the auto run keys. So all the way at the bottom here, run and run once. So if you create a value in one of these keys, when you log in as Windows, it'll look into this and iterate through that list and run whatever programs you have there. So now you have persistence in that regard. Same for this. And there's this tool called Auto Runs, which is part of the sysinternal suite. So if you want to look for common tactics that are used by malware adversaries in terms of persistence, just run auto runs in your blue team competition or whatever. I even run it on my own system sometimes. Something seems finicky, so I'll run auto runs, but it'll tell you what's running, as you start login or whatever. Okay, more stuff. I'll go quickly through this. Sorry, Emmanuel. App-ended DLLs. So this is a bit of an older technique. DLL is a dynamic linked library on Windows, so you can compile those maliciously and basically have your DLL be loaded and execute commands through there. It's a little more stealthy than just having, malware.exe running on a system. This would be under a different process. So what this does, it basically, you put the path to your DLL in this registry key, and it'll inject your DLL into every single process on Windows. So we've seen crashes with this before because your thing is being loaded 10,000 times a minute. So watch out for that. Firewall rules, password filters. So just quickly, there's registry keys where your plain text creds can be sent somewhere. And you have to reboot the registry if you want to edit that usually. Services, I'll just skip over most of this. Services are the same on Linux as they are basically on Windows. They're processes that run in the background. And there's a couple functions that you have to export when you're writing this code. But basically, you can just have a service on Windows. You can change the binaries paths to Windows or to other executables. Okay, John wrote this talk, and he was very Windows focused, so I can see why this is going on. You can do C# or C++ for writing a service. But it's super easy to spot these services running. I wonder what all these services are. So, group policy. Oh man, sorry, Emmanuel. So group policy is part of Active Directory. So basically, this means that there's a bunch of policies in place. Say that you want to set a password policy throughout your entire network. So it uses Active Directory for this. So you set a policy such that you have to have this strong of a password, and then you send it out to all the machines in the domain. So in the case of Red Team, if we have access to the domain controller, then we can send out our own group policy edits. So forcing you to not be able to edit the firewall, not add users, or keep a persistent user, whatever it is, you can do that through group policy. Oh, okay, this is a classic one. Sticky keys backdoor. If you hit Shift 5 times, if you replace the registry key of what binary is executed, you can just have it execute CMD, and then anybody can run whatever commands from the lock screen. Thank you.
Okay, it's almost time, so I'm just going to skip over some stuff. So again, how do you start? I don't want to say you have to pick one, but pick one as a starting ground and just learn as much as you can, and if you feel like that's not for you, you can switch to the other one, like Enzo switching to Linux. Again, just learn how it works normally and just play with it. Look at some known techniques, so MITRE framework, really useful tools. Yeah, look at that. Look at how the threat authors or actors use that technique to their advantage and see if you can implement it in your way. And it's just more practice. Oh, God, John Power. I just said this. You guys can read that later. Okay, I would like to point out this part. It doesn't matter if that tool existed. Like I said, we have like multiple C2s. We could have stopped on like the first 10, but we don't want to stop you from learning. So you can rewrite it if you want. It's just for you to learn better. The first tool is never, again, not as good. You're gonna go through some crappy ones. Then in the middle of in the night, like at 2 a.m., you're gonna have this epiphany right in your biggest red team tool, and it's gonna work. So don't be sad when the first one never works and it never gets used for a long time, because the more you come to practice and just be around similar people, something is gonna click. So oh yes. Any questions? Any questions about red team? Enzo. Oh no, it's like my last slide. It's on Thursdays. I only said side phase because I don't think a lot of you can go. At least a lot of people have been coming, so thank you if you are. But Thursdays, 9 p.m., Galsano 2780, which is the networking lab. If you have any questions, just, oh, yes. It's changed, so you can be red team. It's just you would not be able to compete in competitions as a red teamer. Okay. But you will consider, I do consider you as a red team by just coming to the recruiting meetings. It's just, again, you wouldn't do a lot of stuff and you wouldn't see some stuff. But for the most part, you are a red team by just coming to this. But the 3 blue team is required to compete in competitions. That's about it. Hopefully that makes sense. Any other questions? Nope. And that's it for me.
Clap it up for Emmanuel.
It's demo time. Max, do you have anything to add on demos? He is coming up.
Hey all. Well, I hope that's not too loud. So we're running demos a little bit different this week. Red teaming, there's not really a good demo that I could give you and say, hey, this is exactly how you red team. So instead, we are going to be making some tools, ranging from very simple, where we just have a reverse shell, and also, so ranging from a reverse shell, we'll move into a C2, and then the final one is one of your choice, where you have to implement persistence, deploy mechanism, as well as actual tool functionality. We do recommend a keylogger for that one, just because it's really cool and you can immediately see what you're doing. But again, up to you. With this, it's going to be pretty much sign-off based. Once you have it working, you send it to me or Alex. Our Discords are in the easy challenge if you need them, and we'll give you the flag if it works. This is really the best way to get into it. We've done challenges before where it's pretty much just blue teaming 2.0, but I do think this is the best way to learn, and I hope you all enjoy.
All right.